In example 2, we want to solve each one of these quadratic equations by factoring. So let's see if we can do that. Our goal is to get something that looks like this. A times B is equal to 0. That should be an equal to sign. Oftentimes A is going to be in its own set of parentheses, and B is going to be in its own set of parentheses as well. Notice how we need to have 0 on the right hand side. So we've got that here for the first one. What we need to do now is see if we can factor this. When the value of A, which is the coefficient of the squared term here, is 1, I like to do just an educated guess and check, I'll call it. So we know that the two numbers we're looking for need to multiply to get -6. So we have a few different things we can choose from. We know that when we add them, it has to be -5. So the larger of the factors needs to be negative. So I've got -6 and 1, -3 and 2. Our choice is simply, when we add these up, which pair of these numbers gives us -5, and it is of course this one here. So we've got y minus 6 and then y plus 1. Now if this was just an expression, so if this equals 0 wasn't there and we were asked to factor, we'd be done. However, we need to solve by factoring. So we will now set each factor equal to 0. We'll add 6 to each side here, subtract 1, and we find that y could be 6 or y could be -1. If you want to double check your work, all you need to do is just plug those values back in. So if we use 6, we've got 36 minus 5 times 6, which is -30. So 36 minus 30 is 6, and 6 minus 6 is 0. You can write that out if you want. It'll work for -1 as well. -1 squared is 1. -5 times -1 is 5, and 1 plus 5 is 6, and 6 minus 6 is still 0. Notice how we have quadratics here, so at most we're going to have 2 solutions. At most. We could have 0, 1, and then of course 2 solutions. We won't have 3 or more. With this next one on the right hand side, we see this -20w is over here, and we need that to be a 0. So what we'll do is we'll just add 20w to each side. So we've got 20w here, and then 25, and that's going to be equal to 0. Now what we need to do is we need to see if we can factor this. There's many different ways to factor this. One thing I'm noticing though is that my first term is a perfect square. It's 2w times 2w. And this one is going to be 5 times 5. So this one's worth investigating. We're wondering, could we rewrite it like this? 2w plus 5 times 2w plus 5. We need to make sure that the middle term here works out. And by work out, here's what I mean. If we distributed this out, some people use the word FOIL, we'd do 2w times 2w, which is 4w squared, 5 times 5, which is 25. We just need to check this middle term now. 5 times 2 is 10, that's 10w, and 5 times 2w again is 10w. 10w plus 10w is totally 20w. So this one's a perfect square, or excuse me, perfect square trinomial. So we can set each one of these equal to 0, but we're going to get exactly the same number, so I'm just going to use one of them. So we'll subtract 5 from each side. 2w is equal to -5. We'll divide by 2, and w is equal to -5 over 2. Notice how even in some quadratics you could have only one solution. That's okay. You just can't have more than 2. The next one or C here below the first one, we're going to need to distribute this out, and then we're going to need to get 0 on the right hand side. So if you ever see anything like this, just try to do the distribution here, and this one's going to be c minus 4 times c minus 4. If you prefer, you can just write it out. So we got c squared. We'll have -4c minus 4c, which is -8c. -4 times -4 is 16. Then we'll move everything over to the left side. You can either do that or move everything to the right side. Doesn't really matter. We just want 0 on one side of the equal sign. So we'll subtract c squared here. We'll add 8c. We'll subtract 16. And then everything over here will be just 0. Gone, gone, gone. 2c squared minus c squared is c squared. -13 plus 8 is -5. Oops. Even wrote a plus sign and said negative at the same time. That's kind of weird. 20 minus 16 would be 4. Our task now is to find two numbers that multiply to get positive 4, but add to get negative 5. And that's going to be negative 1 and negative 4. So we'll have c minus 1, c minus 4. Notice it doesn't make a difference if whether you write c minus 4, and then c minus 1 next, or c minus 1, c minus 4 like we have here. So that's going to be c minus 1 is equal to 0, or c, oops, let's make this an or sign, or just the word or. C minus 4 is equal to 0. So we'll add 1, we'll add 4. And c could be, and this might be at the very bottom here, so we'll move that up just a touch. So c could be 1 or 4. Notice how this is not an ordered pair, so we don't use parentheses. These are two values of c that make this original true, and if you wanted, you could check it. The next one's also very similar. We're going to have, if we FOIL this out or distribute this out, we'll have v squared minus 12v plus 36 is equal to 2v squared minus 5v plus 42. Try to get the v squareds over here, and this 12v and this 36 we need to get rid of, so we need to subtract v squared. We'll add 12v and subtract 36 here, so that's just 0. 2v squared minus v squared is just v squared. Negative 5 plus 12, that's 7. 42 minus 36 is 6. So this is another one where we need to find two numbers to multiply to get 6, but add to get 7. So those two numbers are 1 and 6. So we'll set each factor equal to 0. And we'll solve each one separately. And we get v to be negative 1 or negative 6.